Okay, let's take a look at problem 5 now, using a reciprocal function. The rowing club is renting a 57-passenger bus for a day trip. The cost of the bus is $750. 5 passengers will be chaperones. If the students who attend share the bus cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of the function? How many students must ride the bus to make the cost per student no more than $20? All right, so to share the cost equally, we're going to divide 750 by the number of students who attend. So the function model is C equals 750 over 10. The bus has a capacity of 57 passengers, but there'll be 5 chaperones, and the chaperones don't pay. So the maximum number of students is 52. So the domain has to be from 1 to 52. Notice it can't be 0. I need at least 1 student to go on this trip. So if I'm using a graphing calculator, to solve the inequality, 750 over n greater than or equal to 20, we can write 2 different equations. I'm going to use my 2 different equations. So my y1 will equal, and this is also at desmos.com, free graphing calculator. Y2 is equal to 20. And I need to zoom out. Oops. What's going on? Stop. Let me change this. Didn't grab it. Let's just do y equals 20. There we go. Y equals 20. And so I can use my dot to see where that point is, and it's at 37.5. So it said 37.5, but you and I both know that we can't have half students. So we would probably do less than and just say that we would have at least 38 students must ride the bus. So at least 38 students must ride the bus to make the cost less than $20. Okay, let's look at the got it. So it says the junior class is renting a laser tag facility with a capacity of 325 people. The cost for the facility is $1,200. So let's write some of this stuff down. So I know that I have 325 people and the cost is $1,200. The party must have 13 adult chaperones. So let's go ahead and just take care of that. So I know that 13 of those people are chaperones. So chaperones don't have to pay. If every student who attends shares the facility cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of the function? How many students must attend to make the cost per student no more than $750? So, again, we have the same type of scenario. We know C is the cost, and I know that it's going to be $1,200 divided by the number of students N. My domain, I already know, is 1 to 312 students. I have to have at least 1 student go on this trip. Oh, and how many students must attend to make the cost no more than $7.50? I can use my graph for this again. So and I can also solve it too. So please do not feel like you have to do it this way. We can also do it the old-fashioned way of solving. And there we are. I have to move it over a little bit. And we see 160 is right at 750, so we have to have at least 160 people. And I could have just solved for this also. Could have just solved for n if I would have put 750 for my cost. And solved for n, I would have also gotten 160. So I have to have at least 160 students in order for the cost to be $7.50. Okay, let's look at part B. It says the class wants to promote the event by giving away 30 spots to students in the drawing. How does the model change? Now how many paying students must attend so the cost for each is no more than $7.50. So if I'm going to give away 30 spots, I know that this n that I have, I need to change that. So it's not going to be just my n. I need to subtract 30 from that. And now my domain, did they ask me for my domain? No, they didn't, but I'm going to talk about it anyway. My domain would have to be for the number of paying students would have to be I'm just going to subtract 30 from this, and it'd be from 1 to 282. That would be my new domain for my new function. And now if I want to find out for 750, I can solve again, or I can put it in my calculator. So let's just change it here. And let's look for 750. And it's 190. So I have to have at least 190 students attend. I hope that this helps.